Hello there. I've put together some slides and some video to tell you about a project I've been working on for the past 15 months. My project has been to fly radio control, or RC, planes as if I'm sitting in the plane's cockpit. First, for those of you unfamiliar with flying RC airplanes, this slide will help you out. For years, we in the hobby have been standing on the flight line along the runway, like the fellow in the picture on the left. And we'll be holding an RC transmitter and using it to control our aircraft with our eyes glued on our planes as it flies around. You can see what a typical RC transmitter looks like here on the slide, along with the RC receiver that is in the plane to receive control signals from the transmitter. You can also see some typical RC airplanes shown that are representative of what we're flying today. Flying an RC plane or a drone using video from the aircraft is called FPV, or first person view. I have no idea how first person view got to be what it's called, but even now the FAA uses that term, so I guess that's the way things happen. Anyway, basically, what we're talking about here is there's a camera in the aircraft and it transmits real-time video to goggles or a display screen that is being used by the pilot to fly the aircraft. This slide shows what flying FPV looks like. Instead of the pilot standing along the flight line looking at his plane to control it, the pilot is now seated, wearing goggles to see the video that's coming from the plane's camera, and he's controlling the plane with a transmitter. One additional feature that's going on here is head tracking. That's when the pilot moves his head left, right, or up or down a little bit. That movement is sensed by the goggles and then sent to the plane's camera mount such that the camera then moves corresponding to how the pilot moved his head. So if the pilot wants to look over to the left to find the runway, let's say, he just moves his head a little bit to the left, and the camera will look over there to the left. Now let me tell you about the FPV project that I worked on over these past 15 months. You can see the various phases of the project laid out here. I started in September 2024 with phase one. Basically, phase one was doing a lot of research, a lot of watching YouTube videos, and acquiring an awful lot of equipment. There are no FPV kits out there per se for RC airplanes. So one has to acquire all of the myriad of items separately, individually. So camera and various items for the camera, such as antennas, etc. Camera mounts, equipment mounts, additional RC receivers, various special connectors and wiring that you need, voltage regulators that are required, flight controllers, global positioning system or GPS systems. The list is long. It's very long. Then there is designing how all this equipment is going to be installed in the airplane and how it'll all be connected. And then you get into system integration. That is getting all of these things to talk to each other properly and effectively so that the system really works the way you want it to. So there's an awful lot of work in just laying out how this is all going to be accomplished. But then in the winter, I moved into phase two. For phase two, I thought it would be helpful to purchase a drone and learn to fly it, especially fly it FPV, and get familiar with how to use the goggles and how all the various FPV features worked. Once I was comfortable flying the drone and how all the FPV worked, I flew it as if it were an airplane. And I flew it around my airfield where we fly our RC airplanes at our flying club. And I did that to get familiar with the landscape around the flying field from the air, and also to identify landmarks I'd need to use to set up my landing approaches when later I attempted to fly an RC airplane using the FPV goggles. After doing all of that, by spring I was ready for Phase 3, a test aircraft. Phase 3 would be the first time I'd be flying an aircraft FPV using the goggles. So I called my plane Test Article Number 1. I chose a small plane called the Aero Scout. Coming up with a design to fit all of the camera equipment into the small cockpit hatch was very challenging, but it finally worked out. Flight number 1 of the Aero Scout was a tremendous success. Using the goggles, I had a good takeoff, flew around the airfield just fine, did some touch and goes, and had a good final landing. Unfortunately, flight number 2 ended with a crash. I lost video in my goggles. My aircraft then crashed because I couldn't see where it was going. My aircraft accident investigation revealed my video transmission from the plane was operating in what is called low power mode, and I had exceeded the range of that low power mode on that flight. I'd flown the airplane out a little further than I had on flight number 1. I quickly figured out how to get the camera system to transmit in the high power mode. Working on test article number 1 and flying it had taken up much of May and June, but by July I had repaired damage to the camera system and I had installed all of the FPV equipment from test article number 1, the Aero Scout, into test article number 2, which I had chosen to be a Super Timber, a larger aircraft, and it had more room in the uh, cockpit area for the FPV equipment. I flew this aircraft quite a lot during July and August, and I gained much experience flying FPV and using the goggles. This slide is showing what I would see in my FPV goggles as I was coming in to land at our flying field. One of the improvisations I made was to install a small post with a white tip directly in front of the camera. It was positioned very carefully so that I could use it as a reference point for maintaining level flight while up in the air, but it also helped to set up the proper descent attitude when I was coming in to land. And it really helped when I was flaring the aircraft as I was beginning to touch down on the runway. The other big improvement I made to the FPV system was the addition of a flight controller. I chose a SpeedyBee flight controller programmed with the iNav software. The flight controller provides all of the white info you see superimposed on my goggles. You can see the white information there contains altitude, airspeed, heading, my battery level, also very important, the IMU temperature, and also the number of satellites, GPS satellites, being tracked. Having flown test article number 2, the Super Timber, an awful lot during July and August, and gaining a lot of FPV flying experience, I decided to move into the operational phase of the project with a newer airplane, a larger, more typical RC aircraft. I chose a military trainer aircraft, the Navy T-28 Trojan. I moved all of the FPV equipment out of the Super Timber and into the T-28. This is how the T-28 looked in its stock configuration, building it just as it came out of the box. The next slides will tell you and show you how I went about modifying the aircraft for FPV. The first thing I did was remove the canopy off the cockpit area. Then I set about installing the FPV equipment that you see. Here you can see the FPV equipment I installed in the front and rear cockpits. Starting on the right and moving left, you first have the HUD, or heads-up display, which shows a reference point to the pilot. Next is the camera sitting on a pan and tilt gimbal system, which is tied to the head tracking signal that comes in from the transmitter. Next is the video processor, along with its fan to keep it cool. Next is the video transmission antenna that sends video to my goggles. In the rear cockpit is the flight controller, its receiver, the GPS antenna, and a cable for programming the flight controller. This is a better view of the rear cockpit, showing the equipment layout. This is a view of the wiring under the cockpits, where you can also see one of the three receivers in the aircraft and a voltage regulator that was needed as a part of the wiring design. Before I fly, I connect the small red connector that you see to a similar connector on the aircraft battery down in the fuselage. That's how power gets to all of the FPV equipment in the cockpits. This is a view inside the fuselage, showing the lithium polymer battery, receiver number 1, and the power connector that's attached to the aircraft battery. Before flight, that connector that you see is attached to a similar connector from the cockpit, and that provides all the power needed for the FPV equipment. Next will be a video of one of my last flights with the T-28 in November before the winter weather set in here in western North Carolina. The video alternates between a video of what you would see standing on the flight line watching the plane fly and video of what was being displayed in my goggles during those same flight evolutions. I'm taxiing out now, sitting in my chair and wearing my FPV goggles, but taxiing out to get the airplane into position. By the way, we sit down in a chair because standing up wearing the goggles, you might fall over. Okay, you're looking at the view in my goggles now, and you can see the propeller spinning, and we're getting ready for takeoff. All of the white information you see is coming from the flight controller. Taking off, you can see we're climbing in altitude. Straight ahead, you can see the HUD and the green reticle, and above that is the heading. To the left of the green reticle is the miles per hour, the airspeed. Now this is the view of that same takeoff from the sidelines. This is the airplane going down the runway, taking off and turning downwind. And you probably caught a glimpse of my head there as I was sitting in my chair flying, just looking through the goggles. Back in the airplane now, flying and coming around toward the flying field. And you can see to the right of the green reticle the altitude above ground level there, over 300 feet. Now going into a loop and coming down, coming out of the loop, turning downwind. And I'll do an aileron roll here in just a second. Okay. You can see the flying field area there. We rent our field area from the rancher that owns this property. And I'm coming by for a low pass down the runway. And pulling up. In the lower left corner of the display, you can see the number of satellites that I'm tracking. Now this is a view of that low pass, what you would see if you were standing on the flight line as I come down the field. That's Richie Holt there standing. He's my spotter and my advisor. Okay, we're going to do a touch and go landing. And I'm back at idle power now, coming down. I'm going to fly over some horses that our rancher boards. And starting to flare, easing down, and touching down, taking off. And this is what that touch and go looks like from the sidelines.
There you go.
It's a little tricky, I'll tell you.
That's the idea.
I was carrying extra speed there.
Yeah. Another hair of elevator had it been on the mains.
Okay, this is another, and you see that I just looked over to the right to look toward the field, and that was the head tracking. I moved my head a little bit to the right, and the camera looked to the right. Okay, coming back down for another touch and go. And touching down at about 31 miles an hour. That's pretty good. And this is what it looks like from the side of the runway.
Flare. There you go. Perfect.
And you can see me there sitting. Now this will be a full stop landing. This is toward the end of the flight here. You can see by the timer on the far left that I've been basically flying for about 9 minutes. So that's pretty good battery time. That's pretty good flight time on one battery. And coming down and touching down and you'll see the system shut down here in just a second when I come to a stop. And this is what it looks like from the sidelines. And there you have it. That's my FPV project.